what I want to talk about is how we've reimagined our architecture practice around a BIM workflow. And to give you a little bit of context with that, we work in London, there is a lot of work in London, but there's also an awful lot of competition. So there are 33 architecture practices with the same postcode as us, and within a few streets of us, there's probably 1,000 qualified architects. So that the competition is incredibly intense. If you add to that we were really starting the practice and it was really getting going just before the global crisis in 2008, where our fees effectively dropped by 20%, which put an awful lot of pressure on us, and they've never really quite recovered. And that we're working in an increasingly risk-averse procurement environment. It's quite clear that the dream of starting a small consultancy practice and growing it is becoming increasingly difficult. And we effectively saw building information modelling as a way of disrupting that situation. So if I give you a little bit of context of who we are, we're 20 or so people based in central London. We're all in this space around one very large desk. Pretty well all of our work is in central London, on tight, difficult urban sites. And how I personally came to building information modelling was through working on buildings with complex geometry. So for me, this has come from trying to find smoother workflows around design and delivery of complex geometry. It was only then that we started to see the value of structured information, and that's really given the practice a lot of value. So what we actually do, we're a very typical small to medium-sized practice. We work on a lot of housing. About a third of our work is schools, mainly government-funded schools. And the biggest projects we've done to date are projects about this size, so maybe 130, 150 homes, or there's a hotel in there, that sort of thing. So we're still not working on very large projects, they're very normal day-to-day projects. And that's important because we're effectively applying these techniques to normal projects. The practice has probably started to be known for finding technological solutions around tricky problems, but actually it's really the day-to-day approach of applying BIM to normal construction projects that's important. So it's important maybe to look at the motivation for adopting building information modelling. So you're probably aware that in the UK we've got a BIM mandate too, and that actually came into place in 2016. And it would be, that's on government-funded projects. But there isn't a single invitation to tender that comes into the practice now that doesn't have building information modelling in it. Quite often the client doesn't necessarily know what it is that they're asking for, but it is in there. So every project we're being asked for some level of building information modelling. But that's to miss the point. For us, what we're aware of is that as designers, we can add an awful lot of value in a very short period of time with our ideas and what we bring to a project. But that value is then eroded by the process of documenting and communicating those ideas. So building information modelling has the opportunity of maybe keeping some of that value in the project and keeping some of that fee for the practice and making it more sustainable. So what were we attracted by? It was really the opportunity to develop projects in a more collaborative environment where there was shared goals, because the model gives you a shared goal. It was the embedded quality control and coordination and the consistency of our output that was really important to us as a small practice trying to be taken seriously. So as a small organisation, people are waiting for you to fail. And really, these processes allowed us to embed quality control in our way of working that gave our clients lots of confidence in us. And it's at this stage that we started to realise, because we were starting to talk to bigger organisations that were trying to implement the same processes, that we realised that as a small organisation, we had it really easy in terms of adopting these processes. Because effectively, it's all about change management. It's about changing the way that you work and changing the structure within your business. And as a smaller organization, we had a real advantage because we could make the decision and then push it through. We didn't have to do lots of justification and take a big team through with us. So in terms of the timeline of adoption for us, it goes back to 2008. And effectively, we could go through all of the ups and downs. We've done things right, we've done things badly, we've gone forwards, we've gone backwards. But with the information that's available now, it's possible to probably compress a number of years into really a few months of research. But for us, we've been through 3 stages of development, and these 3 stages are really important for a slide right at the very end. So effectively, at the beginning, we were really in a lonely BIM environment. We felt a little bit like a lonely voice. We were using these techniques to increase our efficiency, but there wasn't an awful lot of collaboration going on around us. We then moved into possibly the longest period of time, which was around a sort of more informal BIM environment, where we started to huddle together with construction companies and other consultants who were interested in the efficiencies that these processes could give us. And we started to see real improvement in value at that point. We're now very much in the UK in a contractual BIM environment. So 60% of the work in our office at the moment has a contractual BIM deliverable, where we have to deliver BIM. And that's quite an interesting phase. So if you remember those 3 phases for a slide later on, that would be quite useful. And for us, this is a key slide. We worked on a series of school projects in central London. They're all on tight urban sites. They're all in very special locations. They've often got listed buildings next to them, or they're in conservation areas. So they all have to be completely unique solutions to their particular problem. But what we realized using our models was that we were starting to use the same, the buildings were effectively made out of the same things. They had the same doors, they had the same windows, the furniture was similar, they had the same roofing systems, that sort of thing. So what we were able to do is build a virtual digital kit of parts for this particular building type that could move from project to project, and it could be refined and audited at different stages. So effectively it evolves and becomes better. And what we're able to do is either mine that library when we start a new project, or blow an old project apart and reassemble it. And that really increases our efficiency and our quality control. So that allows us to go into the last project in the series, which is a case study that we'll show you later, where we're able to really hit the ground running and produce a design and a construction very quickly indeed. Having had that realization around the school projects, we then went about developing client and building type specific libraries for different building types and different clients. So different clients and different buildings have different information requirements. And so really what you're doing is developing a library that answers the questions that you need to be asked. So we also realized that size of project isn't a constraint. So when the UK BIM mandate was being discussed, there was actually a threshold, a financial threshold, where it was going to be required. But we actually see efficiencies on our smallest projects, to our medium-sized projects, and to the biggest projects that we do. So we effectively use these techniques on everything, no matter what. We're also seeing opportunities at the early stages of projects. So here what we're looking at is an evaluation of a site. We're capturing the existing context with a 3D model. It's captured through photogrammetry. It's accurate to about 40 centimeters. And that allows us to mass up a version of the building or an option for the building within the virtual context. And the colored blocks have all got basic data attached to them, which is being used to populate the development plan. So that allows us to effectively work out very rapidly lots of different options and see what's best going to work on the site. And we're finally beginning to see clients seeing the value of the virtual asset at completion. So because the model is maintained throughout the design and the construction cycle, at the end of that activity, we have an incredibly data-rich model that has got a huge value going forward. It has a financial value as well as being very useful. So how have we gone about this within the practice? Effectively, we tried to reimagine the practice around BIM. So we wanted to reimagine it not just in the processes that we work, but also the environment that we work in. Because this is a very computer and digital-driven process, there's a danger that people will just disappear into their virtual world. So what we've done is try to generate a lively mission room environment that collaborators will come to, clients will come to, and work in a collaborative, open way. To represent that, the teams sit around a couple of very long desks. So they're talking to each other across the desk and they're communicating with each other. There's a 30-meter long whiteboard to try and get information out of the computer and onto the wall, so they're not sitting in their own little silo. And really it's about communication and collaboration at a micro level as well as a macro level when we get out into the world. There's also approaches to technology, tools and training. There's no doubt an investment required in the technology, in software, but the really important part is the investment in training and getting a team to understand the value of these processes. Virtually, our approach in the office has been to effectively build a best practice management system which captures all of our processes, our checklists and our processes at each of the different stages of a project into a single manual, but underpinning that manual are the BIM Level 2 suite of documents that have been issued by UK government. There's quite a lot of information there, so that there are hyperlinks and deep dives within our manual, which is quite thin, but effectively we've taken the important stuff that our team need to understand and put that front and centre. And on the very first day that someone joins us, they go through this manual. So they effectively, we brainwash them on day one. We reprogram them to work this way. Within that document, we've also captured effectively a BIM plan of work, which demonstrates what the level of detail and effectively what the model and the information should look like at each of those different stages of a project. So we're trying to stop people from over-delivering too early and becoming inefficient. And we found that this has been very positively received by people who come in externally to audit us. So effectively, BIM has been the opportunity to give the office and the organisation a very structured, organised way of working, which is allowing us to punch way above our weight in terms of the projects that we're doing. And on that point, what we think has been really important has been to get other people to come in and independently measure our capability. So we've had external audits from specialists who've come in, looked at our processes, and told us what we're doing badly, in order that we can then sit down, put together a roadmap for improvement. So this is actually a BIM maturity audit that took a few days, and we took in 2013. And from this, we put an action plan together. We've recently done this again. So that continuous improvement is really important. So if I've got time, I'd like to go through some quick case studies to show you how we're putting this into practice. And they're different building types, because we think it's really important to demonstrate that these processes are applicable to lots of different building types. So the very first project is a historic project. It's a series of dilapidated old farm buildings that were being turned into luxury homes. So there are 8 200-year-old barns that are listed, are of historic interest, and we've turned those into 12 luxury homes. So I'll accelerate a little bit. This is the condition that the buildings were in when we inherited them. So they were fairly lost and dilapidated, but they are of historic interest. So the starting point for us was to laser scan each of the 8 buildings. We then built a 3-dimensional digital model of the existing condition. And then within that model, we then started to model what it was going to be, so the interventions that we were going to make within that model. And these can all be phased and demonstrated. So you can see what you're taking out, what you're putting in. And all of the coordination is obviously done within the model. This is just one of the barns. And this is the level of detail that that model could be taken to. So we were able to actually use the early stage model for marketing purposes to try and sell homes in advance. And another innovation for us on this project was that the client within their EIR, within the requirements for the project, asked us to produce a model that could be used for quantity takeoff. So in effect, what the client did was they bought all of their materials from the information within the digital model. So we were able to create a digital bill of quantities from the 3D model. What that allowed the client to do was take the risk in-house of purchasing the materials, which allowed him to save quite a lot of money on the construction. So what that meant we had to do was really understand the naming conventions and the structure of his financial model in order that elements within the model could be named in the correct ways in order that they would automatically populate those bill of quantities. It also meant building the model exactly as the building was going to be constructed. So building the model not to create drawings, but building the model in order to demonstrate exactly how you were going to build it. Another element of this project was a two-way process of digitally verifying locations on site. So we had effectively the ability to take X, Y, and Z coordinates digitally in the field and across the common data environment, communicate that with the design team and vice versa. So we were able to take locations on site and verify that our models are in the right place in the virtual world. And then going back to site, we were able to put little digital diamonds within the model that give an X, Y, and Z coordinate that allowed them to set out construction on site. So there was no traditional setting out on site. It was done with digital techniques. This is it in action. And the key element of this is that communication across the cloud using that common data environment, that cloud-based FTP site. All of the team on site were trained to use the techniques, and the contractual deliverable for the project was actually the 3D model, not the drawings. So that if the team were looking for dimensions on the site, they were able to take the dimensions directly out of the model themselves. They didn't rely on us giving them the dimensions. That cloud-based common data environment allowed us to invite other people into it as well. So whether that's the contractors or the suppliers or even the end users could access the model and in a very transparent way see what was going on. I'll flip forward. One of the nicest elements of this was obviously the historic frame of the building was the bit that was very special. And the carpenters were trained to use the tools. And what they would do is photograph a piece of timber before they worked on it, pin it digitally within the model, and then photograph it afterwards. So we have a complete audit trail of all of the work that happened on the timber frame. And this is them in action. So this is the building under construction or under refurbishment. One of the particular barns, we dropped a new cross-laminated timber structure into the middle of it in 10 days. And the model for this was CNC cut from the digital model. And this is it completed and at the end. So the next project I wanted to talk about is another building of significance that is quite precious. And the issue here, this is actually a project I worked on 20 years ago, and we were approached by the client to refurbish it now. And effectively it's a press box for a sports ground. And in the intervening 20 years, the building's become fairly dated because technology's moved on. An example of that is the building's actually got a dark room in it, or did have a dark room in it, which is now a bar, which is much better use for it. So the issue here really was, or the advantage of putting this project into the presentation is we can talk about some of the things that we did then, some of the things that we're doing now. So we effectively had an opportunity to go back and correct some of our mistakes. So the building itself was a prototypical off-site construction in the early 90s. So it had very early CNC cutting. It was fabricated off-site in sheds, and then effectively brought to site in large elements and erected on site. But all of the information was generated in an analog way. So we actually started we started the information in pen and ink and completed it in very simple CAD. So the information is 2D. The other thing that's quite interesting is, and I think this is very relevant to building information modeling, is when we completed the job, I remember very distinctly packaging up all of the information and distributing it to the client, the contractor, and the architect. We kept a copy. In the intervening period of time, all of that information was missing. So effectively, when we came to refurbish the building, we didn't have the information we required in order to do that. So the concept of the building was to shrink fit the shell around the existing, shrink fit the shell around the program of the building, around the interior spaces, which really gives you nowhere to expand the building. But it was now no longer big enough to do what it needed to do. So you can see the shell there. So in order to preserve the function of the building, we had to be able to get more function into it and to update it. So we were going to put an entirely new interior in it and all new M&E mechanical and electrical systems. But we don't know exactly what it is that we've got to work on. So our starting point was to laser scan the exterior of the building, and then using the drawings that we could find, build a model of the external shell. We then laser scanned the interior of the building, so we've verified the external shell, we laser scanned the internal shell, and we're looking for voids between the inside and the outside in order to push the interior further out and increase the inside space of the building. So we did this digitally, and interestingly, finding the form of the original building took a few months. Modeling the external shell took us 4 days using the technology that we've got now. So we've built a model of the external shell. Then we've effectively been through an extremely careful coordination exercise with the mechanical and electrical systems to push them into as small a zone as possible against that external shell, bearing in mind that this is all double curved as well. That then allows us to push the architecture further out. And the outcome of that is that we've effectively increased the internal floor area of the building by 15%. So using the techniques that we've got now, compared with the techniques we had 20 years ago, we're 15% more efficient with the building now than we were then, which I think is a very clear metric. Marvellous. I'll flash forwards. So really, it's that extra coordination that the model can give you has a real value. There's some other nice things that come out of it. So these are CGIs taken straight from our digital model while we were trying to demonstrate what we were going to do to the building. And these are the photographs afterwards. So you can see that the CGIs were done in-house. There was no extra cost involved in that. And you can see that it's a very true representation of what you're going to get, which again gives the client confidence. I'm going to flick through the next bit because of time and go on to another building type. So this is Mayfield School, and this is a government-funded school project in East London. And the critical issue with this project was that it was effectively the program. So we had 18 months from a blank sheet of paper to handing the building over. And if it wasn't including all of the design, stakeholder engagement, and approvals, and if that wasn't going to be possible, then effectively the solution was going to be a standard solution, which wouldn't have been ideal for the school. So using the techniques of that digital kit of parts and some interesting construction techniques, the team committed to be able to do that, and we managed to achieve it. Really what we were having to do is hit the ground running with a digital model. So we're using that kit of parts to get a fast start. We were actually able to get the project to planning, to be submitted for planning in 7 weeks. So the design was, the early stage of Project Bassico was completed in 7 weeks. Including all of the stakeholder engagement using the digital model, which gives the stakeholders and the users of the building a buy-in as to what it is that they're going to get, and a confidence of what it is that they're going to get at the end. It goes without saying that all of the coordination of the consultants' work was done through the model, but probably the most interesting element is the structure and the journey the structure went through in the building. So the building is made out of cross-laminated timber, which is like very thick plywood. In the early stage model, we were given rules by the engineer to design by to ensure that it could be built with CLT. Those rules, the structure was included within the architecture model. There was a point where we then took the structure out of the architecture model and brought in the structural engineers model, and we continued to coordinate with the structure and the mechanical and electrical systems. And then once the specialist supplier for the timber frame was on board, we then took the structure out and we put the supplier's model into the project and continued that refinement of the coordination. So this is the model from the specialist timber supplier. And their model starts to have the cutting patterns and the addresses of all the different panels on it. So we were able to carry on coordinating right until the night before they pressed the button and cut the panels in the factory, which meant that there was an awful lot. There was a much higher level of coordination than there perhaps would have been without being able to bring that model, keep that model live right until the last minute. All of the components have got an individual address, and then those addresses can then be used to manage the logistics of bringing the panels to site. So we knew which panels were on which lorries and when they were going to arrive, so which effectively eliminated the need to double handle and store panels on site. So panels could just be lifted straight into place. Again, this is all to do with just managing information and data. This is a photograph of the site under construction. And this is it completed in 2014. Right. This is actually a very short one because this is a project that we're working on at the moment, but I think it's relevant because it's public funded housing. it's the same team and the same client that worked on the historic barns project. So we used a lot of the techniques that we had there on this project. But the thing that is different here is that it's a modular off-site solution to the site, being managed entirely through level 2 BIM. So the key gains here is a very high level of quality control, because every component within the project has a unique address and a unique identifier. It can be tracked throughout the process of it moving through the factory onto site and through to sign-off. It's effectively, it's 130 new apartments. There's 50 unique types of apartment. So there's a certain level of solving the issue around mass customization. And those apartments are made up of 500 units that have been made in a factory in the north of England. So in effect, we have two construction companies working on the project. We have the construction company that are building the modules in the factory, and we have the construction company that is managing the site and building the envelope around those modules. So the thing that both construction companies and all the suppliers and the stakeholders have in common is the digital model. So that's the thing that they're using to hold all of this together. So this is a typical 2-bedroom apartment. It's made up of 3 modules, each of which can go on the back of a lorry. And every component and every element within that unit has a completely unique address. So the elements that need to be managed are barcoded, so they can be checked that they're in place in the factory, again, once they're on site. And this is all, again, being managed through the common data environment. So there's a complete audit trail of everything that happens through the construction of the project. So as I was saying, the key thing here is the one thing that everyone on the project has in common is this shared digital 3-dimensional model and data set attached to that 3-dimensional model. So it's allowing more people to be involved in that project. And again, these are just snapshots from the tools that the team are using on a day-to-day basis to manage all of the communication on the project. So there's no email. Everything is managed through the common data environment. All design team meetings are recorded in the common data environment. Effectively, there's a list of actions that can be checked off. And because it's structured, we can see what's happened, what hasn't happened. So it gives early warnings if things are starting to drift off course. And you can see who's performing and who isn't performing. So that transparency is just making for a much more attractive way of working. So here we have some photographs of some of the modules ready to be delivered to site, and that's really the stage we're at. We've got about half of the modules on site, half of them in the factory at the moment. So if I could just quickly, in the last few minutes, go through the return on investment for us. So because we're a small organisation, we've got nothing to hide. I thought it'd be quite useful to share what this has cost us. So for us, we think it's cost us £12,000 a seat, so effectively $15,000 per person. I've been suggested that the idea of saying seat isn't a good idea because it suggests that everyone's sitting at a desk. Obviously, they're much more mobile now as well, so per person, not per seat. That includes the costs of the hardware, the software, and most importantly, the training. There was a few additional costs in there that we weren't expecting, like having to upgrade our server and our network to manage the sheer quantity of data that we're moving around. And also because we're increasingly using cloud-based applications, we've also invested in fiber optic internet, which has a certain cost to it as well. But if you break that investment down, what I think is quite interesting is that pretty well half of that investment is on training. And I think if you've got really good staff, it's really important to train them to make sure that they stay, make that investment in your team. For us in London, we're in a very competitive environment. It'd be very easy to lose staff if we weren't keeping them at the forefront of technology and keeping them happy and motivated. And these techniques do give younger people in an organization the opportunity to take more responsibility earlier in their career. Because there's that structured, quality-controlled system behind them, you can give them a lot more responsibility a lot earlier. And then if you look at the pink line, that's effectively the cost of building information modeling relative to our technical staff costs, effectively our salaries, and all of our other costs and our profit. So you can see that building information modeling is actually quite a thin line that runs through that process. And this is the key diagram, I suspect, and this is going back to the very early one, which is measuring our costs and our BIM costs against our fee income over a period of time. It's a little bit out of date because we've carried on, but I think it's very relevant to the conversation that we're having here. And what you can see is that when we were in that early, lonely BIM environment, we were seeing a little bit of an increase in our efficiency, but it was staying broadly parallel. Once we were in that informal BIM environment, we saw a real increase in our efficiency, and it then plateaued. And what we thought that was as far as it was going to go, that we gained that efficiency by working with other collaborators in this very shared space, but that's where it was going to land. Now that we're in that contractual BIM environment, we saw another lift in our efficiency, which is counterintuitive. So we thought that we were effectively now going to be involved in a lot more bureaucracy. We had new roles in the office to manage building information modeling now that it was contractual. We thought that would effectively take the edge off the efficiency. But what we found is it's actually improved our efficiency greatly. Where that's coming from, we now realize, is the fact that we've got a much more structured way of working. We have a roadmap for the project from inception. People are doing the right thing at the right time to the right level of detail. So we're not over-delivering too early, and we're not under-delivering when it really counts and people need information in a hurry. So for us, we're quite confident that BIM has given us an opportunity to reimagine our practice, and it gives an opportunity to holistically encompass our workflows, our team, our working environment, our external interfaces, and the model has promoted collaboration with our clients, with our collaborators and construction companies. It's allowed us to add real value to those situations. It's also allowed us to find new roles within the process, and we've expanded our role within design teams, and offer more services, which really, for us, I think, in the early days, allowed us to survive in the difficult financial situation post-2008, but now is really allowing us to thrive as a business. So using this model, we've achieved year-on-year profitable growth, and 90% of our work comes through repeat business with existing relationships. Which we think is, which means we're not spending lots of time and money chasing new work. We're keeping our clients and we're keeping our collaborators because of that consistency of output and that reliability that building information modeling gives us. And I think it's demonstrated that the UK government's BIM targets of 2016, which people thought were a big stretch and a big ask, I think it's proved that those targets were actually very achievable and make absolute economic sense even for a small business like ours. And so in effect, that clear direction and leadership from UK government empowered us and gave us an opportunity to build a much stronger business. We believe that as a small organisation, you can actually lead on digitally led innovation. So effectively, BIM is a disruptor, and it gives an opportunity for smaller players to punch way above their weight. So organisation size is not a barrier to BIM adoption. And most importantly, we think that aligning our practice with this way of working has made it a much better place to work and a much happier atmosphere. So with that, thank you for listening.
Plan BIM, una iniciativa del Comité de Transformación Digital de Corfo.